Have you ever noticed this? Some websites shows a lock icon with HTTPS while others don't and only show HTTP. At first glance, they might look the same, but behind the scenes there is a huge difference. What does this actually mean and how does it protect you from hackers? Is your data really safe or can someone still see what you are doing online? In this video, you will understand everything about HTTP versus HTTPS and why one small S can protect your entire digital life. Let's get started by defining HTTP. HTTP stands for Hypertext Transfer Protocol, which is used for transferring data over the web and has the default port number 80. Whenever we talk about the internet, there are two main components, the client and the server. When a client submits a request by entering a URL in the browser address bar, a request is sent from the client computers to the website server. This data travels through the internet as plain text until it reaches the server, where the website is hosted. The server then sends back a response to that request, and the browser renders or displays the data on the web page. But the real problem arises when hackers come in between the client and the server. Because the information is sent as a plain text, a hacker can intercept and extract sensitive data while it travels to and from the web server. This could include information like your name, address, credit card number, and some passwords. That's where HTTPS comes in. HTTPS stands for Hypertext Transfer Protocol Secure. It is a combination of HTTP with the SSL TLS to supply encrypted communication and to distinguish the actual web server. It has its default port number 443. Now when you submit your request via HTTPS, the information is encrypted before it travels across the internet to the web server. So when an attacker intercepts that data, they won't know the sensitive information and they also won't know the response that the web server sends back, because that too is encrypted. HTTPS is now the main protocol for transferring data across the web because it protects user information from being compromised. Now, if this was difficult to understand, let's look at it with an example. Suppose Iron Man wants to send a package to Thor. He arrives at the post office where there is a delivery person, Thanos. If you drop off a package at the post office, Thanos can open your package, steal its contents, or tamper with them. This is like HTTP. But when your package is enclosed in an indestructible safe, Thanos might still see the package, but he won't be able to open it. Only the people with the key can see what's inside the safe. That's like HTTPS. Now let's understand what actually makes HTTPS secure. HTTPS uses SSL TLS to encrypt the communication between the client and the server. But how does this encryption really work? You might have heard about something called an SSL certificate that every secure website uses. But what exactly is it? And how does it protect your data? Let's break down the working mechanism of SSL TLS step by step. Let's suppose we have a client at one end and an Nginx server at the other end. The whole point is that the client wants to communicate with the Nginx server. The easiest way is not to apply any encryption method. The client will make a GET request and the server will return a response. The problem in this architecture is that any middleman can snip the communication. Let's say we have a hacker who can easily snip the request and response. This is called a man-in-the-middle attack. So our goal is to secure the communication between the client and the server. Now the interesting part begins. How do we encrypt the communication? Suppose we have data such as a text or a password. For this, we need a key to encrypt the data. The same key is used to both encrypt and decrypt the data, which is called a symmetric key. Let's suppose the client has the key which it uses to encrypt the data. The data is then sent over a GET request to the server. However, the problem is that the Nginx server can't read the data because the key is not available on the server side. The server cannot decrypt the data because the key is only with the client. At this point, the key must also be transferred to the server. But if we try to transfer the key freely over the network, a hacker can intercept it and keep a copy. So, if we communicate in the future, the hacker can also decrypt the messages. So the condition is that both the client and the server must have the key, but the hacker must not have access to it. In this scenario, we use another type of encryption called the asymmetric encryption. In asymmetric encryption, we have two types of keys, a public key and a private key. The public key can encrypt the data and only the private key can decrypt it. In this case, we have data that need to be transferred from the client to the server. First, the server has two keys, a public key and a private key. The server provides its public key to the client. Even if a hacker gets a copy of the server's public key, it is okay. Then the client generates its own symmetric key and encrypts it using the server's public key. Now this encrypted symmetric key is sent to the server. Even if a hacker intercepts it, they cannot decrypt it. The encrypted key can only be decrypted using the server's private key. The server then decrypts it and keeps a copy of the symmetric key. Now both the client and the server have the same symmetric key and secure communication can begin. The hacker cannot decrypt the data because they do not have the symmetric key. Until now, we haven't talked about the SSL certificate. Even in this scenario, there is still a possibility that the communication can be compromised. Let's see how. A hacker can act as a proxy. When the server sends its public key to the client, the hacker can intercept it. The hacker can create their own public and private key and send their public key to the client instead. Now the client generates a symmetric key and encrypts it using the hacker's public key. When this encrypted key is sent, the hacker can decrypt it using their private key, obtain the symmetric key, and then encrypt it using the server's public key before sending it to the server. Now, when the client sends data to the server, the hacker can intercept it and decrypt it using the symmetric key they have obtained. The client thinks it is communicating securely with the server, but in reality, it is communicating through the hacker. So, how do we protect against this type of attack? There is where SSL certificates come into play. As we know, our server has its own public and private keys. To verify its identity, it uses an SSL certificate which is issued by a trusted authority. Let's suppose the authority is Fire Vendor. The server requests Fire Vendor to generate an SSL certificate. To do this, the server provides its public key to the Fire Vendor. Fire Vendor also has its own public and private keys. It creates a certificate that contains the domain name of the website and the server's public key. The certificate is then signed using Fire Vendor's private key, creating a digital signature by combining the server's public key and the Fire Vendor's public key. Now, when a connection is established, the server sends both its public key and the certificate to the client. The client is not sure whether the public key belongs to the server or a hacker, so it verifies the certificate. Since the certificate was issued by Fire Vendors, the client uses Fire Vendor's public key, which is already trusted, to verify the signature on the certificate. If the signature matches, the client can be sure that the public key belongs to the real server. If the public key had been from a hacker, the signature will not match. Once the verification is successful, the client trusts the server's public key and the secure communication process continues. This is how an SSL certificate works. Let's see it in a website. If you open any website and click here and open connection is secure, then there appears certificate is valid. Here you can see the issuer and there is a certificate and the public key. If you go to the details, then you can see the person, its serial number, issuer, etc. And the certificate actually carries what. This is all about HTTP, HTTPS and SSL certificates. Thank you for watching. If you want to understand how a domain name is converted into an IP address, check out my previous video on how DNS works. And if you want to learn networking step by step, make sure to follow my TCP IP model playlist and don't forget to subscribe to the Gaurabs Tech for more such content.